So next, we're going to explain how to solve the equation of motion by some assumptions. Firstly, what the problem here is that we know some information from n step, and we're going to find out the response in n plus 1 step. This is a time step by step integration method we're going to use here. Firstly, we're going to assumed how the acceleration changed from an to n plus 1 in this small time interval of delta t. And first, most simple way to consider about that, we think between n step to n plus 1 step, a time interval is delta t, and the acceleration is changed by consider their average. Okay, so we just say that at n plus delta t step, n times of delta t, the acceleration is an. However, suddenly it changes to the average of the an plus 1 between an until n plus 1 step, it suddenly changes to n plus 1, something like this. However, between them, the acceleration will not change. It's constant. Although the acceleration will be described as a time step of the n of t. So as we mentioned before, that the velocity is the differential of delta t delta d about t, where delta d is incremental of displacement inside the small time interval. And a also due to the ratio of the velocity and the second differential of displacement. Okay, inside here, the difference between n plus 1 and an is delta n plus 1. However, we are going to consider this later. And about the ground motion, we say at the n step, ag is agn, and n plus 1 step is agn to agn plus 1. And acceleration changed from an to n plus 1 at n plus 1 step. And between them, we consider the velocity will be accumulated by the acceleration. Where acceleration is here is at is average of an and plus 1. Here we say is average of an plus 1. By accumulate them, by calculate the equation, we say we have a constant, which is Vn at n plus n step, and we have the velocity increase until here to here by this linear, because in a is constant at this time. Okay, so what is going to becomes at the end of the delta t time interval, it becomes use delta t as t, to instead into this equation. Okay, so make t becomes delta t, then we'll find Vn plus 1 equals Vn plus half n plus n delta a plus 1 delta t. However, still n plus 1 is a variable that we don't know yet. Okay, let's change another consideration about how the acceleration changes. Still, we have n, we have an, we have n plus 1. However, between an and n plus 1, I think they change linearly. We can observe that from n step to n plus 1 step, their time interval is delta t. And between n and n plus 1, their distance is n plus 1 minus an. So the gradient here, this solid line, will have this gradient will be n plus 1 minus n divided delta t. We consider until an to n plus 1, the acceleration changed linearly from here to here. This is sound more real than the average acceleration. The average is more simple, but this is more real. However, the equation becomes a little bit more complicated because we have changed the variable here for the an. Okay, it becomes more smooth by accumulating them together. Use put this equation into the accumulation integration. And by solving this equation, we can extend them like this, so that Vt will finally becomes like this. Thus, we calculate n plus 1 by this equation. Vn here is constant value, which is ant will be changed to delta t, and this is part of incremental part with second time about accumulation. So Vn plus 1 finally will becomes Vn plus half n plus an plus n plus 1 delta t. So what is different between these two methods if we compare them a little bit like this? You can find that Vn plus 1 and calculated from average and linear method, they are exactly the same result. That means that even we make a more simpler assumption, use average acceleration method. When you calculate acceleration in this very small time step interval, there will be no difference between them. How about displacement? Let's see it later.